This video is about the product rule, and this rule is used when we have a function that is a product of two simpler functions. So an example here would be f of x equals x plus 2 x minus 5, and we can clearly see there the two separate functions, x plus 2 and x minus 5, two separate functions. Another example, f of x equals x squared minus 5x plus 6, there's one of them, and sine 3x plus 5, there's another. Okay, so you can see there the situations we're going to be using what's called the product rule. We've got the product of two functions. Careful, because sometimes people think that this is two functions, and I'll show you this here. So for example, cosine x squared plus 5x plus 6. Some people think that's two functions. They go, oh look, here's one function, cos, here's the other function, that. No. That is not correct. There's the one function there. They are not two separate functions. So delete the idea of that being two functions out of your mind as I delete it out of this presentations. Alright, here's the product rule. If y equals u times v and u and v are two separate functions, the derivative is, here we go, u multiplied by the derivative of v plus v multiplied by the derivative of u. Putting it in function form, if you've got f of x equaling u of x times v of x, f dash of x is the first function multiplied by the derivative of the other, and the derivative, the second function multiplied by the derivative of the first. Okay, so it's a little process there that we use to work out derivatives of products. Here we go, let's use it. First thing we're going to do here is identify that it is the product rule, and it is the product rule because we've got one function here and another one here. Okay, the purple and the red one. So it's two separate functions. And what we're going to say here is that one of the functions we call u equals 3x minus 1, and the other function v equals x squared plus 4x plus 3. Then we proceed to get du dx, which equals 3, and dv dx, which equals 2x plus 4. Now it's time to use our rule. dy dx equals u times dv dx plus v times du dx. Now we've got our four components here. 1, 2, 3, 4. That shouldn't be too hard to get. So let's start the rule. So it's dy dx equals u, which is 3x minus 1, multiplied by dv dx, which is 2x plus 4, there, plus v, which is x squared plus 4x plus 3, multiplied by du dx, which is 3. Now instead of tacking the 3 on the end here, of course we can put the 3 on the front, like so. There we go. We can multiply this out now. If we multiply out this first set of brackets here, we get 6x squared plus 12x minus 2x minus 4. Remove the second lot of brackets, we get 3x squared, should be 12x there by the way, 3x squared plus 12x plus 9 equals 6x squared plus 3x squared is 9x squared. 12x minus 2x plus 12x is plus 22x. Minus 4 plus 9 is plus 5. There's our answer. Okay, next one. A bit more complicated. Find the derivative of log 4x to the base c times sine 3x minus 2. So once again we're using our rule here, which I'll paste over to the other side here. Our product rule. There it is. Oops, wrong slide. Beg your pardon, let's do it over here. Squeeze it in the corner there where we can see it. Okay, so there's our rule. And of course we identify before we go any further, that u is the first function. It doesn't have to be the first one, but best to work from left to right. And v is the second function. Okay, so du dx equals derivative of 4x is 4 over 4x, and we should know by now, in fact, that the derivative of anything x to the base e is just 1 over x. Okay, so we would have got it the long way anyway, but it's 1 over x. Dv dx, derivative of sine is cos, so we get the derivative of 3x minus 2 is 3. Cosine, bracket stays the same. Let's apply the product rule. So it's u, first of all, so there's our u. So it's log 4x to the base e, multiplied by dv dx, multiplied by 3 cos 3x minus 2, plus v is sine 3x minus 2, multiplied by du dx, which is 1 over x. Let's copy that to the next slide and we'll start tidying it up. Okay, so we've got two bits here, the left-hand bit and the right-hand bit. So we look at that one. Best way to clean that up is to make sure that 3 there pops out the front. So we've got 3 log 4x to the base e cosine 3x minus 2. If you've got a coefficient stuck in the middle like that, please put it out the front. And the other one, the 1 on x really should be at the front of that expression. So it's 1 on x sine 3x minus 2. There we go. There's the answer. Next one, a bit more complex. And with our u this time, instead of putting 1 over square root of x, that's x to the power of negative a half. And it's best to put it in that form so that it's easy to differentiate in a moment. Our v is negative 6 sine 6x. So cos goes to negative sine, derivative of 6x is 6, and 6x stays the same. So du dx equals negative a half x negative 3 on 2. Dv dx equals, oops, sorry, I mucked up there. I got the derivative first. Let's see, sorry. That's the derivative. And that's the original cosine 6x. All right, now we've got those straight after a little bit of trouble. Let's apply the rule. So it's f dash x equals u, which is x to the negative a half, times dv dx, which is negative 6 sine 6x, plus v, which is cos 6x, times du dx, which is negative a half, x to the power of neg 3 on 2. Let's fix up the left-hand expression here. And I'm going to do a couple of things at once here. So we've got negative sine 6x, and we've got this here, this x to the power of negative a half. Now remember, to make a negative index positive, we have to put it underneath the fraction line. So it becomes x to the positive a half, and of course x to the positive a half is the square root of x. All right. The other one, we've got, we're going to take the negative a half out the front, so negative 1 over 2. We've got the cos 6x on the top, so let's look at that. So we'll write that up there on the top, cos 6x. Let's extend that a little bit. And on the bottom we've got, or on the top at the moment, we've got x to the power of negative 3 on 2. That can actually go to the bottom, and that becomes x to the power of 3 on 2. Just about done. But you might remember that x to the power of 3 on 2 is actually, if I just, actually I might just copy this over the next slide and do it, just that very last step. I'll go to a new slide, here we go. So we've got it to here. So the answer will be equals, this one's okay. This one, that x to the power of 3 on 2 is also the square root of x cubed. Why is that? Because x cubed, the square root of x cubed is x cubed times, to the power of a half, sorry, and that's x to the power of 3 times a half is 3 on 2. Okay, so that's my answer there. I'll put a nice red box around it so we can see. All right, one more question. Find f dash pi if f of x equals 3 minus x tan 2x. So here we're very much looking at an exam standard question. So let's get the derivative first of all. So let's, first of all, step 1, find f dash x, okay, for our function over here. And to do that, we need to find our u and our v. So there's our u, and there in yellow is our v. Alright, so u equals 3 minus x, therefore du dx equals negative 1. dv dx, oops, v, first of all, v equals tan 2x, therefore dv dx equals, now there's a couple of ways of doing this. I might use cosine here, so it's going to be 2 over cosine squared 2x. Alright, so there we've got our derivatives ready to go. Now we're going to apply the product rule. So dy dx equals u, which is 3 minus x, times dv dx, okay, which is 2 over cos squared x, cos squared 2x, beg your pardon, plus v, which is tan 2x, multiplied by du dx, which is the one we haven't used yet, which is negative 1. So we're multiplying tan 2x by negative 1. All that happens here is we get a negative out the front of that. In fact, then I can also, plus negative is a negative. So I'm now down to this. Might be a good idea too if I bracket the 3 minus x. And let's look at what we've got. Now if we put this over the next slide. Here we go. Alright, what we've got now, on the top here, we've got 2 outside of 3 minus x over cos squared 2x minus tan 2x equals 2 outside of 3 minus x. I'm going to make this expression here, instead of cos squared 2x, I'm going to make it cos 2x squared, because in a minute we're going to substitute pi in here, and that's going to be important, minus tan 2x. Fantastic, we're now ready to do our substitution. We've now found f dash of x. So, put that over. We're now, as I said, ready to find f dash of x. So f dash of pi, which is the question. So that's f dash of x we've found there. Okay, so tidy that up a bit. There we go. So to find f dash pi, now we have to substitute pi into our equation where we've got x. So it's 2 outside of 3 minus pi over cos 2 pi squared minus tan 2 pi. Okay, so on the top there we've got 6 minus pi over cos 2 pi. You can look up your table, or you might know already, is cos 2 pi is 1, so it's 1 squared minus tan 2 pi. Also looking up the table is 0. And that gives us an answer of 6 minus pi. Alright, so there's the introduction of the product rule. So just remembering the product rule again, go way back to the start here. If you've got two functions together, it's the first function multiplied by the derivative of the other, and the second function multiplied by the derivative of the first. Should be able to now do exercise 7H. That's all for now.